Hello, everybody, and welcome to this session. My name is David Klebanov. I head product marketing for a company called Alkira. And today I wanted to talk to you about an exciting topic of building networks for the cloud era. And more importantly than talking, I actually wanted to provide you a demonstration of the solution so you can see what it means to build these networks for the cloud era. Now, before we step into this, I wanted to spend a second to set the baseline of where networking is today, right? And for us networking folks, I don't think any of this will come as a surprise. When we think about networking today, and not just the cloud networking, because obviously cloud is a very front and center for a lot of organizations, a lot of enterprises, but it's not just about cloud networking. It's just networking in general. If we think about the networking in general for on-prem environments, for cloud environments, for multi-cloud environments, we can really track a couple of sort of sore points, right? We know that many of the solutions that exist in the market really address just an individual piece of the puzzle. So it turned into kind of a disjoint solution landscape. We know that many of the solutions are anchored on hardware investment and costly hardware investments. We know that software configurations, complicated software configurations, is something that a lot of enterprises are struggling with. We know that specifically for cloud, we know that a gap in expertise and in cloud networking expertise is something that is a really acute pain point for enterprises. And at the end of the day, it all turns into slower provisioning and the way that the networking team is delivering the service back into the organization. And bottom line, we can all agree that the networking for today or of today is not sufficiently agile for this, enterprise cloud needs. So how are we going to address this? Right. So before I jump into the details of the demonstration we're going to see, I'm just going to spend 1 minute describing to you this notion of an Alkira network cloud, which you can think about this as a cloud network infrastructure delivered as a service. Just like the cloud itself is delivered as a service to the enterprises, the idea here is to deliver the networking, security, and operational capabilities as a service to the enterprises to consume. Right. And what it boils down to is this infrastructure is used, it's offered as a service that enterprises can build their networks that connect their users, sites, cloud data centers, on-premises data centers into this sort of infrastructure and provision network and security services in this infrastructure, such as, for example, firewalls, in order to secure the communication within this environment. And of course, on top of all of that, an intuitive interface that allows you to really go and do all the operational provisioning, troubleshooting, monitoring tasks. Right. So specifically for the demonstration, what we're going to see in here, we're going to see an environment that is stretched across two geographic locations, US East Coast and US West Coast. It is interconnected through what we call a cloud backbone, which is a high-speed, low-latency, secure network, right? That is a foundation, the backbone, the core of your connectivity within your environment. And the cloud backbone consists of what we call the cloud exchange points, which are a virtualized points of presence where everything connects to. And in this case, what we're going to see is we're going to see VMware workloads and multi-cloud workloads. So as far as VMware workloads, for workloads that exist for on-premises environment, the software-defined data center workloads, those would be connected through the IPsec tunnels to their closest cloud exchange points. So those on-premises virtual networks can communicate to the multi-cloud workloads and also to the workloads that are provisioned within the VMware cloud for AWS environment. Now, specifically for VMware cloud on AWS, it's going to be similar, but sort of like the reverse, is that that environment is going to be also virtually connected into the cloud exchange point. Both the VMware cloud on AWS and the cloud exchange point, both are in the cloud. So this is cloud-to-cloud connection. And once it's connected, it's going to be able to communicate to the on-premises software-defined data center and also to the multi-cloud workloads, in this case, a Microsoft Azure workloads. Now, in addition, we're also going to add an on-premises site, so you can see how on-premises branch offices can be plugged into this, and firewall security and intent-based policies in order to symmetrically steer the traffic towards those firewalls. All right, so having said that, let's see how it's actually done. So the first thing we'll do is we will log into the portal, right? This is how you consume the environment, because it is offered as a service, right? So we know that. Apologies. We know that this environment is offered as a service, so we know that that's how you consume it. Now, these are the cloud exchange points that you're seeing on the screen. So the first thing we're going to do is we're going to add a location. In this case, it's a software-defined data center, right? And it's going to have an IPsec connectivity into the cloud exchange point. So we need to define the routers. Those are the customer gateways that exist in the software-defined data center. And because it's data center, there's going to be two of them. So we're going to have this as a redundant connection. The public IP address is the one that is an IP address on the internet connection at that data center location, so it can establish an IPsec tunnel. Now, over that, we will do BGP in order to exchange routes and assign two more things. First one is the network capacity, and second one is the segmentation story to connect that software-defined data center to the rest of the environment. Now, you can see the software-defined data center was connected. Now, the second thing we're going to add is we're going to add another IPsec connection. And in this case, this is going to be a connection for VMware Cloud on AWS. Now, we, again, need to define an endpoint, which is the IPsec termination. In this case, it's an edge router. And the IP address, which would be the elastic IP address of that edge router, in order to establish an IPsec tunnel to the Alkira Cloud Exchange point. And again, BGP for dynamic route exchange and sizing of that connection from the networking capacity standpoint, the segmentation. And now you can see the VMware Cloud on AWS was added into this. Now let's add more, right? Let's add now an AWS workloads, right? These are the cloud native workloads that do not reside on VMware Cloud on AWS environment. So we're going to select the AWS account that we want to use for authentication. Now the system goes and discovers all of the AWS VPCs that exist in that account, allows us to easily select the VPCs, and then provide, again, the two pieces of information as far as what is the network capacity that is going to be delivered to this AWS VPC, which segment it belongs to, and then allows us to just go and save that. And you can see that AWS VPC was also added. It's in a different region. It's on the East Coast. So you see that we are talking about East Coast, West Coast, just like I explained in a setup for the demonstration. Now, the next what we're going to add is a multi-cloud workload. So we're going to add Microsoft Azure workload, the VNet, into the environment. So again, selecting an account and allowing the system to discover all of the VNets in that account. All right, so we're going to select that VNet. And now, similarly to what we did with AWS, we need to provide two pieces of information to the system. As first is the network capacity that is going to be delivered to this Microsoft Azure VNet and the segment that it's in. And then we can save it. And Microsoft Azure VNet was added into the environment. So now we have an on-premise data center, a VMware and cloud environment, native AWS, and native Microsoft Azure workloads. Now, lastly, we're going to add the branch site. This is where some maybe of on-premises users that need to access any of the application workloads reside. And again, it's another connection into the Alkira Cloud Exchange point, a definition of a router with a public IP address, a BGP for route exchange, and network sizing capacity, and the segment that this connector belongs to. Now you can see that now we've created this entire diverse environment that stretches between the on-premise and cloud environments. Now what we're going to do next is we're going to provide security. So security is going to be provided through instantiating a Palo Alto Networks VM series firewalls within the Alkira Cloud Exchange points. So Alkira takes care of the entire process of provisioning the firewalls, licensing the firewalls, making sure that Palo Alto Panorama server can manage them, and make sure that the Palo Alto VM series firewalls are also automatically scalable to the real-time capacity demanded by the application traffic. So in this case, you can see that we can simply select what is the minimum and maximum watermarks for the firewall scaling. And in this case, it's between 2 and 4 firewalls. So when fewer capacity or lesser capacity is needed, 2 firewalls for redundancy, more capacity is needed, 4 firewalls, and we can go beyond that. Now, segmentation is something that is extended to the firewalls. So firewalls can enforce zone-based security policies. Again, similar things around how much network capacity is delivered to the firewalls and saving this. And you can see the firewall was instantiated in one of the cloud exchange points. So I'm going to skip doing the same thing for the other cloud exchange point, but it would have been the same. The last thing we need to do is to create a policy that actually steers the traffic to the firewall. Typically, it's a pretty complicated process, especially when firewalls being symmetric sort of stateful entities require symmetry in the traffic forwarding. In this case, it literally just showing the intent of who needs to communicate to who. In this case, it's the on-premises software-defined data center communicating to the VMware Cloud on AWS environment and just making sure that that traffic goes to the Palo Alto firewall. Now, all we can do is just enable this policy and save it. That is how easy it was to really symmetrically steer that traffic to the firewall. Now, similarly, we can add another policy that basically would have a different influence. So I'm just going to show it to you so you can see that it's not just limited to a VMware environment. I can create a policy, calling it the cloud policy, within a certain segment. And in this case, I can select that this is going to be, a VMware Cloud on AWS environment communicating to Microsoft Azure VNet, which is a native cloud workloads. Again, making sure that traffic goes to the Palo Alto firewall, enabling the policy and saving this, right? So you can see that in literally a matter of minutes, I was able to build an entire network and insert services and symmetrically steer the traffic towards those services. So hopefully you enjoyed the demonstration. So I'm going to leave it at this. And if you have any further questions, you are more than welcome to visit our website at alkira.com, and where you're going to find a lot more information, details, and you can also request your own personalized demo of how the Alkira solution can sort of work in your environment. Thank you so much, and have a great day.